Think about how many hours you've spent with a computer mouse in your hand. Thousands, right? It's probably one of the most direct connections we have to the digital world. But have you ever actually stopped to think about how it works? Like, really works? I mean, really think about it for a second. How does this little plastic thing, with no ball or wheels on the bottom anymore, translate your hand moving on a desk into a cursor moving on a screen with, like, pixel-perfect accuracy? What's going on down there?
Well, it's not magic, even though it kind of feels like it. It's a tiny little camera that's taking something like 17,000 pictures every single second. Yeah, you heard that right. So for the next few minutes, we're going to dive deep into how this amazing piece of tech actually pulls it off.
Okay, so at the very core of all this is something called the Image Acquisition System, or IAS for short. This is basically the mouse's eye, and it's made up of three key parts that have to work together perfectly.
All right, so first up, there's an infrared LED. It shoots a beam of light down onto your desk or mouse pad, a light we can't even see, by the way. That light bounces off the surface, gets focused through a tiny lens, and bam, it hits an image sensor which snaps a picture. And this whole cycle, it happens thousands and thousands of times a second. It's wild. So what's really fascinating here is what that sensor is actually seeing, because it's not capturing the color of your desk or, that cool galaxy print on your mouse pad. Nope, it's looking for something completely different. To you and me, our desk might look totally flat and smooth. But to the mouse's sensor, that same surface is this huge, complex world. It's a landscape of microscopic hills and valleys. And the way it sees this is pretty genius. Think about it like this. The infrared light hits the surface at a really, really shallow angle. It's kind of like a sunset casting long shadows across rolling hills. The tops of those microscopic ridges catch the light and shine bright, while the tiny valleys get cast into deep shadow. This creates this super high contrast black and white map of the surface's texture. And hey, this totally explains that super common frustration, right? Why your mouse just doesn't work on a glass table. If a surface is too perfect, like glass, there are no hills or valleys for the light to create those shadows. No texture means no picture, and if there's no picture, the mouse is completely blind. It has no idea it's even moving. Okay, so the mouse can see this invisible landscape. That's cool, but how does seeing a still image translate into tracking movement? Well, the trick isn't in just one picture. It's about comparing thousands of them at, like, lightning speed. Seriously, let this number just sink in for a second. A really good gaming mouse can take up to 17,000 pictures of that tiny little patch of your desk every single second. That's just an incredible feat of engineering. And here's the really wild part. The mouse doesn't save any of these pictures. There's no secret photo album of your desk hiding in there. Instead, its little brain, its processor, instantly compares the brand new picture it just took to the one it took just 59 times microseconds ago. That's 59 millionths of a second. It's just looking for what changed. So, the mathematical magic that makes all this possible is an algorithm called cross-correlation. This is all handled by a tiny chip inside the mouse, a digital signal processor, or DSP. So, how does this whole cross-correlation thing actually work? Well, imagine the processor takes one picture, we'll call it image A. Then, 59 microseconds later, it takes image B. It basically lays image B right on top of image A. By comparing the two, it can see exactly how the pattern of hills and valleys has shifted. The processor then calculates the precise direction and distance it needs to move image B to get it to line up perfectly with image A again. And that calculation, okay, I had to shift it 2 pixels to the left and 1 pixel up. That is exactly what tells your computer where to move the cursor. And it does this thousands of times a second. Just wow. Okay, so all this amazing tech also explains a term you've probably seen thrown around all the time, especially with gaming mice: DPI. What is it, and how does this sensor tech let them get those insane sensitivity levels? Right, so first things first, what even is DPI? It stands for dots per inch, and all it really means is this. A higher DPI means your cursor will fly across the screen with just a tiny little movement of the mouse. A lower DPI, you gotta move your whole arm to get from one side to the other. So you might think that a high DPI mouse just has a sensor with way more physical pixels packed into it. And that's part of it, but it's not the whole story. The real secret sauce is creating virtual data points, what they call subpixels, from the information the real pixels are giving it. Yeah, this clever trick is called interpolation. The processor looks at a little group of 4 real pixels and checks their light intensity values. Then it literally just draws imaginary lines between those data points and mathematically calculates new points in between them. It's basically subdividing 1 real pixel into many, many smaller virtual subpixels. So think about this. When you go into your mouse software and you slide that DPI setting way up, you're not actually changing the hardware inside the mouse. You're just telling the processor's algorithm, hey, make more subdivisions between the real pixels. You're literally just changing the math. So when you put all this tech together, the super fast camera, the cross correlation, the interpolation, that's what creates the huge difference in performance between, say, a standard office mouse and a high-end gaming mouse. Just take a look at these specs side by side. It's pretty stark. A gaming mouse can have a DPI of 25,000 or even higher, compared to maybe a few thousand for a regular one. It's taking over 4 times as many pictures per second, and it's reporting its position to your computer up to 1,000 times a second, where a normal mouse might only do it about 120 times. All of that adds up to that super fast, super smooth, and incredibly precise cursor movement that gamers need. All right, so let's just boil this all down one more time. The crucial things to remember are: your mouse is basically a super high-speed camera. It sees texture, not color, using an invisible infrared light. It figures out movement by comparing thousands of pictures every second, using that cross-correlation algorithm. And finally, that super high DPI is all thanks to a mathematical trick called interpolation, which creates subpixels out of thin air. It's just an absolutely incredible amount of sophisticated technology all packed into this simple, everyday device that we totally take for granted. It really makes you wonder, doesn't it? What other everyday tech that we use without a second thought is hiding a secret that's just as clever?